Hello. We are starting our next section in our circle chapter, and that's going to be going over congruent chords and arcs. Now, this is going to be a little bit of a shorter section. I go through every single type of problem with you, but you're going to get more practice doing those problems through my math lab, all right? Okay. If we have congruent chords and arcs, there are some special relationships or assumptions we can make because those are congruent. So if two chords are congruent, then we can assume that their corresponding arcs are congruent. So in this example, if AB and segment CD, so the chords are congruent, well then this whole arcs are going to be congruent as well. So arc AB is congruent to CD. If it's known that our chords are congruent, we can also say that the segment that travels between the center of the circle and the chord, those segments are going to be congruent. So here in this example, my chord is AB and my chord is CD. Well, then these segments that travel between those chords are congruent. So EF is congruent to EG. Okay. And finally, if AB and CD are congruent, we can claim that the diameter or radius is going to be perpendicular to the chord. Okay. And because of that relationship, that they're perpendicular, it's going to divide that chord into two equal parts. So AF is going to be congruent to BF, and CG is going to be congruent to DG. Why does this all matter? Why is this all important? Well, you could be given a certain section of the circle, and it's like, hey, solve this. Okay. By the way, these chords are congruent. Okay. So if you have congruent chords, you can say that its corresponding arcs are congruent, that the segment that travels between the chord and the center, so that radius or diameter, is going to be congruent. And then also the radius and diameter will divide that chord into two congruent parts. So let's look at some examples. We are trying to find X, and it already tells me that chord RS and ST are congruent. Therefore, my arcs are going to be congruent as well. Because of that relationship, I can set those equal to each other. So 115 is going to be equal to 7x plus 24. I'll be honest, this chapter involves a lot of algebra skills, so woohoo, it never goes away. All right, first step, subtract 24. Giving me is 115 minus 24. 91 is equal to 7x. X is equal to, drum roll please, 13. Oh, there, Hot Mess Express. Not too shabby. All right, let's look at another example. Here, I'm wanting to try to find XY. What is the distance or the length of segment XY? Well, XY is actually a chord. Here, it tells me that my arcs are congruent. So if my arcs are congruent, that corresponding chord is going to be congruent. So I can set those two quantities equal to each other, solve for X, and then plug in for XY. So 9X minus 34 is going to be equal to 4X plus 1. I like to keep my X's positive, so I'm going to subtract 4X over. And then I'm going to add 34 over to the other side because we want to isolate that X. So 9X minus 4X gives me 5X. 1 plus 34 gives me 35. Divide by 5. X is going to be equal to 7. But that's not my final answer. That's not what it's asking for. It's asking for XY. So I'm going to plug her back in and solve for XY. So 4 times 7 gives me 28 plus 1. Give me a final answer of 29. There we go. Winner, winner, chicken dinner. All right, example 3. In circle Z, find each measure. Okay, this is going to be kind of composing all of those rules that we looked at the beginning. Okay, so let's take it step by step. I am wanting to find segment TV. TV. Okay. One thing I know when I have congruent chords is that radius and diameter is going to divide my chord into 2 congruent parts. So all of those parts are congruent. Based off the information it told me that RS is 18. So what is those 2 sections going to be equal to? Well, I'm going to take 18 divided by 2 to give me 9. So each of those little sections is 9. So TV is equal to 9. TU is that whole chord, and our chords are congruent, so TU is going to be 18. I want to find WS. So WS is going to be equal to 9. All right, so our next thing to solve is for YU and RS. If YT is 42 degrees, what's the distance of YU going to be? Well, TY is 42, so YU is also going to be 42 degrees. The next thing I need to solve for is RS, and if RS is congruent to TU, I can add up both of these sections to equal RS. So RS is going to be equal to 84 degrees. There you have, folks. All right. Our last example, and this example is a little bit fun because you are bringing back your triangle theorems. So here I am wanting to try to find the distance of, or the measure of the length of segment VW. VW. And I'm wanting to try to find the arc measurement of YW. So, looking at our picture, how are we going to get to those quantities? How are we going to do this? I need to find this long segment right here, VW. All right. Well, I have a triangle there in the middle. Okay. One thing we know about chords is that its radius is going to divide it into 2 congruent parts. So VZ is going to be congruent to ZW. So if I can solve for ZW, I can multiply that by 2 to get VW. So how would I find ZW? Well, Pythagorean theorem. Okay, I have a right triangle. I have my hypotenuse. I have a leg. I can solve for that other leg. So I'm going to take 5 squared. I'm going to make this x. 5 squared plus x squared equal to 13 squared. So 25 plus x squared is equal to, isn't that 126? Let me just double check. 169. Okay, minus 25 minus 25. X squared is equal to 144. What's the square root of 144? That's going to be 12. So if one half of these is 12, this other half is 12. 12 plus 12 gives me the length of VW, which would be 24. Okay. All right, there's VW. My next thing is I want to try to find the arc measurement of YW. How am I going to go about that? Well, I have a right triangle in there. And what do I know? What's the relationship between central angles and arcs? They're congruent. So if I can find the angle of YXW, I can find the arc degree measure of YW. How am I going to do that? We're going to use something called trig ratios. All right, so here's my angle. What information do I know? I know adjacent and hypotenuse. So I'm going to use cosine because SOHCAHTOA, adjacent, opposite. My angle, I'm going to make that y. Cosine of y is equal to 5 over 13. Remember, I flip those and make it the inverse. So the inverse of cosine of 5/13 is equal to that angle measure. Remember, make sure your calculator is in degree mode. All right, so second cosine of 5 divided by 13 gives me an answer of angle measure for YXW, but it's also equal to the arc length YW. That is going to equal 67.4 degrees. Okay, so I'm telling you, this information we've built up, these skills we've built up along the way this semester, they do not go away. So in this section, you use your triangle relationships of trig ratios and Pythagorean theorem. Okay, and that's all I have for you today. So this section is really looking at the relationships of congruent chords and arcs and applying them through algebra. Okay, if you have any questions, let me know. See you guys.